Okay, Jeanette, since we are having a hard time getting together in Blackboard Collaborate, I thought I would just make a little video and answer your questions. And you can let me know after you watch this. If you still have questions, feel free to reach out to me. The first question that you had was about negative exponents. So I think this may have been the problem that you were talking about. And there's also another one, 1 all over I to the negative 11. So we're going to work both of those problems. Again, this is addressing the question in your email about negative exponents. Now with negative exponents, I always start out by making them positive. So that I to the negative 13 is going to move down to the denominator and become positive. And then I rewrite that power of I to the perfect fourth. I know that I to the fourth is 1, and so if I can take this 13 and make it, as a combination of 4 and some other number, it'll make my calculation easier. So here I'm going to put cubed, so I to the fourth cubed, so that'll give me I to the 12th, and then I have 1 I left over. Okay, and so here, this I to the fourth is just 1. So 1 cubed is just 1. So what I'm ending up with here is 1 all over I. I can't leave my answer like that because you can't have an imaginary unit in the denominator. So to alleviate that, we multiply by its conjugate. So remember to divide a complex number, you multiply by the conjugate. Okay, so that's kind of the trick there. That's what I'm doing. And so here, multiplying straight across, we end up with negative I all over, and then we're going to take this product. So this is negative I squared. I squared is just negative 1, and so the opposite of a negative 1 is a positive 1. So your final answer is just negative I. Okay, and then the second problem is 1 all over I to the negative 11. Just like the previous problem, I'm going to make that negative into a positive by moving it. So this time I have to move it up to the numerator. So it becomes I to the positive 11. Again, I want to rewrite that as a perfect fourth. So I to the fourth to some number will get me close to 11. So if I put a 3 there, I'll have 12, which is too many. So I'm going to have to settle for a 2. That will make 8. And then I have 3 left over. Okay, so this right here, this quantity right here is just 1 squared, which is 1, and so my final answer is I cubed. And then you can further simplify that. Remember your powers of I. We have I squared, which is negative 1, because I is the square root of negative 1. And then we have I cubed, which is I squared times I, so that would just be negative I. And then I to the fourth we've been using as 1. So this is kind of that basic pattern that you want to make sure you remember. And so instead of I cubed, we can just write negative I. So your final answer for this one would be negative I. Okay, and then we'll continue on. The third one that you asked about was the square root of negative 3 times the square root of negative 8. So the product rule for radicals does not hold because the indicated roots are not real. So the first thing you have to do is take these negatives that are under the radical, pull them out front, right? So that will become I times the square root of 3. This, when you pull the negative out, it becomes I times the square root of 8. Now you're multiplying, so we're going to multiply I times I. That'll give us I squared. Then we multiply the square root of 3 times the square root of 8, which will be the square root of 24. Then we're just going to clean up. So I squared gives us a negative 1. Since 6 times 4 is 24, that allows us to pull a 2 out front. So that will be a 2 times the square root of 6. And kind of putting all that all together, you have negative 2 times the square root of 6. All right, and then you asked me a problem. It was x minus the square root of 4x plus 12 equals 0. And I worked it out in the video, so this wasn't a you try it problem. What I'm going to ask you to do with this one is just rewatch that video that is posted in Blackboard, and if we need to meet and collaborate, we can, and talk about that one. All right, and then in that first email you sent me, you referred to this problem here, the x cubed minus 125, and the question was, well, where did that answer come from? Where did the quadratic come from? So let's talk about that. This is a difference of cubes. So if you remember, the formula for the difference of cubes just says that if we have a cubed minus b cubed, it factors into a minus b times a squared plus ab plus b squared. So again, that is a formula that you need to make sure you know. So that's a difference of cubes. If it was a difference of squares, like if this was x squared instead of x cubed, then yeah, x squared, you could use the other formula. So, like x squared minus 25, for example. That factors into x plus 5, x minus 5, right? But this is not a squares problem. This is a cubed problem, right? So here we go. Let me just get a little eraser here so we don't have so much going on. So I'm going to erase the part we don't need. So here we have x cubed minus 5 cubed. So everywhere in the formula that I see an A, I'm going to put an X. Where I see a B, I put a 5. And so then you can see the answer emerge. When I plug in, here I have an A, so I'm going to put an X. Here I have a B, so I'm going to put a 5. And then x squared plus 5x plus, and then 5 squared is 25. Okay, and that was it for your first email. The second email had some very specific questions about word problems. So let me see what this one says. It says, in reference to the area here, the surface area of the can, you wanted to know, why do we use the quadratic formula instead of the square root formula? So I'm not sure what you mean by the square root formula. I mean, we have, in that section, we talked about, the square root property that says if x squared equals k, then x equals plus or minus the square root of k. Again, that was called the square root property. Okay, so by the square root formula, I'm thinking maybe you're talking about the square root property, but at any rate, you cannot use this for this particular problem because it does not fit that format of x squared equals k. So the problem, once you worked it down to the quadratic, it was 371 equals 24 pi r squared plus 2 pi r squared. And maybe that's just pi r. The older I get, the more help I need seeing. So I need to put my glasses on. But anyway, there we go. So this is the equation. And so, again, there's no way to get it in this form right here because it's not something squared equals something. You have a linear factor in there. Not only do you have a quadratic and a constant, you also have this other r term, right? And you don't just have r squared. So having said all that, that means that we're going to have to use the quadratic formula. So the quadratic formula, tells us that if we have x squared plus bx plus c equals 0, then x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So, you just reorder this, and that's in the video, so I'm going to refer you back to that, but we'll just walk through just a minute of it. We have 2 pi r squared plus 24 pi r minus 371 equals 0. So, here's your A, here's your B, and here's your C. And you're just going to put those values in the quadratic formula. All right, so hopefully I've addressed that question. If not, let me know. And then your other question is about the geometry problem and having negative numbers. So with this problem, the problem was w squared minus 12w minus 160. And we factored that into w plus 8, w minus 20. Okay? So when I solve that, it's w plus 8 equals 0, w minus 20 equals 0. That's using that zero product property. So you solve that, you get w equals negative 8 and w equals positive 20. Now from this point here, this is where I assess and say, okay, if I have a negative physical measurement, I have to toss it. And so you can't have a negative width. Therefore, I tossed the w equals negative 8, and we just keep the positive value for the width. Okay, so hopefully I've tackled all those questions. If there's anything I've missed or anything you still have questions on, feel free to reach out and let me know.